Okay. Hello, everyone, and welcome to our webinar on the case for OS diversity and independence. Quick overview before we get started. We're going to start with introductions, myself and Alex, and then talk about what a monoculture is and what problems it poses. Then talk about selecting the components to build something that's not a monoculture, and then some of the practical steps for implementing this kind of diversity. And then move on to talking about how we can avoid duplicate work and just some of the gotchas that you're going to want to avoid as you do this. And then we'll take your questions and then we'll wrap up. So to start, I'll introduce myself. Hi, I'm Alan Jude. I'm the co-founder of Clara, where I'm the ZFS engineering manager and deal with all that. And I'm joined today by Alex Kruchmar, who's a host of the Self-Hosted.show podcast. And a Red Hatter who works on OpenShift and is here to talk to us about the Linux side of things.
Yeah, hello. Nice to talk to you, Alan.
Yes, and thank you so much for joining us.
You're welcome. I will admit I was watching a video on YouTube the other day with you in it where, you know, Wendell's got this reputation of being tech support for the internet. And I think you are now tech support for Wendell. When ZFS is involved anyway. That was so funny to me.
Yes, it was great to get to work with Wendell too. So we'll get started. So what is a monoculture and why is it bad? So a monoculture is a system where everyone relies on a single component or technology, leaving the entire ecosystem vulnerable to potential security flaws or system failures. It's kind of like a monopoly. When one software has a monopoly on everything, then they control everything. And that isn't always good for us or resiliency, right? If everyone uses the same component because that's the only component there is or the only one supported, then that puts the entire system at risk of collapse if something goes wrong with that component, whether that's because the author pulls it off GitHub or because GitHub shuts something down or just one of many different reasons. If the business behind it goes away, all kinds of things like that, then everyone's left in a situation where there was only one component, they relied on it, and now it's not there. You know, when we build data centers, we take all this effort to make sure that everything is diverse, right? We're pulling power from 2 different substations and we have diverse fiber paths. So if a backhoe kills all the fiber out of the one side of the building, there's still another path. And then all this, and we have redundant sets of batteries and everything feeding into a machine with dual power supplies and redundant hard drives. And then we run exactly the same software on every machine. We've only protected ourselves against the hardware side of the problems, not the software side.
There's a lot of crossover in real engineering terms with regards to redundancy that I think as software engineers and infrastructure people, we've still got a lot to learn and a lot to do.
Mm-hmm. So yeah, the key point of our presentation today is that nothing should be irreplaceable. Each component should have an alternative. And ideally, you'll be using at least 2 of these, or at least one additional version of everything, so that when something bad happens, it's not that you have to switch to an alternative, it's just that some fraction of your infrastructure is already using that alternative. So you want to avoid having all of your business depend on any one single technology or library or whatever it happens to be, so that ideally you're able to quickly adapt to the loss of any single component. All right, and that things keep working as soon as that component goes away, not, you know, oh, we can rebuild it with a different component, but, you know, it'll take a while. And whether that's, again, something like what happens with NPM, where suddenly a component is used to distribute a protest. So the component's actually actively sabotaged to delete files from your system. Or we see things with sanctions and GitHub pulling important tools like IPMyTool off of the platform. And, you know, if you depend on that component and being able to pull it and build it, then now what do you do? And, you know, your infrastructure must be designed to be resilient against software failure just as much as physical failure, right? We all think about what if a hard drive fails, what if a power supply fails, and we have all that redundancy built in, but then we don't think about the same thing for software, just like Alex said. And I think one of the biggest things that happened to highlight this was when Heartbleed happened with OpenSSL, because OpenSSL was and pretty much still is a monoculture. It underpins almost all the TLS on the internet, outside of some libraries that, if you're using a Windows server or something. There are some alternatives like GNU TLS and so on, but they're not very well supported by software, or there are some forks of OpenSSL like LibreSSL and BoringSSL, but those tend to just be OpenSSL with a bunch of bits stripped out. Because Heartbleed in particular was a prominent component that maybe most people didn't really need, and a question of why was all this bloat in OpenSSL in the first place, that led to making these stripped down versions of OpenSSL. But if the vulnerability is something core to TLS, then it's going to be the same code in LibreSSL, BoringSSL, and OpenSSL. So sometimes a fork isn't different enough to actually provide the kind of resilience that we're looking for in this particular case.
Something as central as OpenSSL, though, how would you go about? We'll come on to the operating side of stuff shortly, but how would you avoid that pitfall? I suppose everybody
Really,
understands and
there needs to
uses
be a second library that applications can actually use, and maybe that means that we need a more common API. I think Amazon tried to do that a bit with their S2N version that could then be backed by different libraries, but yeah, the biggest problem is that if you use something other than OpenSSL, your application needs to support that. And some applications do. Like if you're using, like curl, for example, can build against 3 or 4 different TLS libraries. And having that option and actually maybe using it and exercising it so that if there is a bug in OpenSSL, some of your curl installs are not impacted by it, can help make sure that not only do we have the option of these other things, but those options are actually well tested and used. A lot of times support for these other SSL libraries seems to be kind of an also ran, which is okay. But if we don't have enough effort going into testing and using those alternative libraries, then they're not production ready, and that doesn't help us solve the problem.
I think it's part of the problem when you look at, any infrastructure in general. Banking is a good example. You look at what runs the core of the banking industry, and it's technology from the 70s, from the 80s, HP non-stop systems, old mainframe stuff, old in air quotes. And how would you go about replacing it? Because the replacement spec is what's already there. And so if you're the business, you're not going to invest in replacing it because you've already got something that works fine for my needs, right? So there does need to be an open source movement, I think, to kind of help run these projects in parallel.
Yeah, because especially if what you want is something that works exactly the same as OpenSSL and works with all the same programs as OpenSSL, you're basically asking somebody to spend all this effort to recreate OpenSSL, but different under the hood, which is great, but it's harder to make the business case for that. And so after Heartbleed, when we acknowledged the fact that OpenSSL was maintained by some volunteers with a budget of a couple $1,000s a year, basically, they tried to improve that. And we came up with this idea of the Core Infrastructure Initiative that was going to collect money and distribute it to these important infrastructure bits of open source software. But as we've watched over time, that got subsumed by the Open Source Security Foundation. And looking at their report from 2022, they spent all their money on things like Node.js and JavaScript libraries, and no money on actual core infrastructure components like TLS or SSH or operating systems.
At what point do we ask the big companies in the world to have some responsibility in this field, though?
Well, that's what the Open Source Security Foundation was supposed to be. Companies like Microsoft and HP and Dell are all pitching into this. It's not actually seeming to be directed at the actual core infrastructure bits.
Yeah, but it's not enough, clearly. I mean, if there isn't enough to go around, I mean, it's a huge business risk for these companies. If OpenSSL went away tomorrow, I mean, the internet would break as we know it, for starters. But just from a pure business perspective, which is what these guys understand, there has to be some accountability towards open source projects. They love to Sherlock stuff, and pick the best bits of open source and rebrand it and sell it on. there's got to be a bit of give and take, I think, or
Yeah,
more give
well, I
and
think
take.
especially in this case, when we're looking at picking components to build our infrastructure out of, you want to make sure that when you're picking an alternative component to use for some fraction of your infrastructure, that it's got alternative, a different supporting entity behind it. If the funding source for both OpenSSL and this alternative SSL library are the same, then it means if one gets cut off, it probably means the other one does too. And so just as much as we need diversity in how the software works and who maintains it and so on, the kind of funding model and where the support comes from also needs to be different. Just again, back to the analogy of the data center, we want no single point of failure, right? Everything needs to have two completely isolated paths.
We've talked a little bit about a lot of the pitfalls of a monoculture in the last few minutes, but it's important to look at the security aspects as well. So when a security flaw comes along, such as Heartbleed, it impacts the entire ecosystem. And in this case, OpenSSL runs across every major OS. We're talking Linux, FreeBSD, macOS, everybody uses it under the hood. And if there's a vulnerability in one, there's a vulnerability in all of them. The other thing to consider is that the patching life cycles of a lot of these OSs are vastly different. The speeds with which, even just within the Linux world, for example, the speed with which Arch moves compared to Red Hat Enterprise Linux moves, it's a very different beast, as you would expect, because they serve different targets, right?
Mm-hmm.
But the idea is that by having a monoculture here or avoiding it, we can try and avoid some of those pitfalls of that, commonality between those different systems.
Yeah, and like when we saw something like Heartbleed, usually it comes out as, here's the warning that there's a thing and there will be a patch on Tuesday. It's like, okay, so what am I supposed to do until Tuesday? If I have an alternative, I can shift more of my infrastructure to using that at least, or a way to mitigate this until the fix is able to be put in production. Especially, we're going to want to test the fix on our side and make sure it doesn't cause other problems or huge performance penalties or something. Like when we look at the CPU disclosure vulnerabilities, like Spectre and Meltdown and so on. It's like, there's mitigations for these, but they nuke like 25% of your performance. It's like, well, it'd be really nice if I had an alternative that I could have been using in the meantime.
Yep. And the same is true, when they released the patches for Heartbleed with OpenSSL 3, resulted in significantly worse performance. And the upshot of that is, for small folks running a small web server, probably doesn't matter. But as soon as you start running these things at scale, every few percent, those marginal gains, they add up. And so if you add a few percent through a Spectre and a Meltdown patch, and then you add a few more percent overhead with an OpenSSL patch, and by the time you're 50% slower than you were a couple of years ago, just through patches and mitigations for various vulnerabilities. And so, in a perfect world, we would have one OS on, an Intel chip and one OS on an AMD chip, and they would be completely different, and they would be running different SSL libraries. And by the end of the day, not only do we have, like Alan said, redundant fiber channels coming into the building, redundant power supplies, etc. You've got redundant CPU architectures, redundant software architectures, and the layers all the way up until you get to the end user actually using your stuff. There's a redundant path there somewhere in case something falls over.
Yeah, and like especially even if we are going to admit, okay, we're going to need to add more capacity because the CPU mitigation is required and can't go away. If we have an alternative we can use in the meantime, we can put more of our infrastructure on that while we wait for more hardware to arrive or whatever. But just having some agility to deal with the problem temporarily until we can implement the better solution, or there's a second revision of the patch that doesn't have as much performance impact or whatever. Oftentimes with these kind of security vulnerabilities, it's like plug the hole right away and then we'll fix it properly in the next cycle. And that can be fine, but if it causes a problem, having no alternative means you're left having to just suck it up instead of having something you can do about it.
It's one of the reasons I always laugh when, the Xbox versus PlayStation wars come into it. NVIDIA's better than AMD or Intel's better than AMD because they make the GPUs and CPUs these days. I almost said ATI. These arguments are just so flawed because there has to be alternatives at every layer of the stack in order for us to succeed here. You could even go so far as being paranoid about stuff like who makes the NAND flash on your SSDs, for example, and say, like, I need a redundant controller so that I don't fall foul of a firmware bug in one particular SSD, et cetera, et cetera. That might hurt your performance for various reasons. But when it comes to failure time, if you order all the drives from the same batch, even, there's all sorts of stuff we can do. We're talking about software today, not hardware typically, but
it's all the same concept, right? Is we want the diversity and we have to have it basically all the way up the stack. And even, that brings up the point of like, the reason why we tend to have 2 or 3 competitors and suppliers for each of these components is because that's also what drives the innovation.
Mm-hmm.
And so if we just have one monoculture, it's maybe it'll continue to innovate, but not necessarily in the same way and at the same velocity and in the direction that we want it to.
I'm trying to imagine a world where there was only one car manufacturer. Can you imagine how terrible that would be?
So terrible. So moving on to our next segment, we're talking about some of the criteria you might actually use for selecting which components to use. And in particular, as promised, we're going to focus on the operating system level.
Absolutely. And near and dear to my heart, because I work on OpenShift on a daily basis at Red Hat, is the Immutable operating system. And this is a hugely important topic to understand. It's a relative, I say new, but we just covered on Linux Unplugged just this week how Docker's now 10 years old. And so the concept of containers for normal people, I know Alan, jails and FreeBSD have been around forever, but us normal people in the real world haven't actually come across containers until about 10 years ago when Docker made them popular. And so when you start thinking about running applications as units on top of an operating system, you start to question why you even need a package manager on your operating system at all. Because if everything's in its own isolated, almost like a cheroot, if everything's in that container, why do I need the operating system to have all of this cruft around it? Surely I want to be able to take the operating system out back and shoot it in the head and then bring up another one and it just work. That's the idea of an immutable operating system, cattle versus pets. I'm sure you've heard that analogy before. It comes with the idea that it's each instance is identical out of the box. And so you don't download an operating system and then customize it with a few packages here and fettle a few config files there. The idea is that all of those customizations happen within a container. And so the base image that you're running across all of your infrastructure should be identical. Now, what's interesting is that sounds a bit antithetical to everything we've just been saying for the last few minutes. And it promotes a bit of a monoculture, right? And so the idea would be not to run the same image, the same operating system image on every host. Maybe you have a Kubernetes cluster based on one distribution, and then you have some failovers in your load balancer to go and run application containers on a different set of systems from a different vendor, perhaps. Now, the idea behind an immutable OS is you boot it up and then destroy it, like I said, and it's almost entirely got a read-only file system. There's a couple of exceptions that you can make some modifications that will persist, and this is dependent upon the OS in question. I'm most familiar with Red Hat's Core OS because that ships as part of OpenShift. And it has the concept of layering packages on top of the base OS using RPM OS tree if you really must customize the base OS. However, unless you have an extremely good reason, I would probably suggest avoiding that. What's better is to actually build a new image as part of your continuous integration system and then deploy that. So you're not you're not running, say, an Ansible playbook or something against these hosts every time they're created. You can also, with OpenShift, use something called a machine config to inject things like custom system D units and users and all sorts of other stuff. Install, Puppet agents if you really want to, all that kind of stuff. So the customization options are there if you're in a paradigm, and I see this a lot with public sector customers. If you're in a paradigm where there's a lot of monitoring and alerting and rules and stodge to wade through, you can make these immutable OSs fit that mold, but they're best suited to more agile, static environments that run primarily containers.
Yeah, and since we're proposing the idea of being able to diverge your infrastructure and have two components for everything, one alternative to using various different Linux distros, which we've talked about, are again in the end all the Linux kernel and maybe not distinct enough. Looking at something like FreeBSD, which provides a Unix environment very much like Linux, but is a completely distinct kernel with a completely different 30-year history of supporting the same kind of interfaces and the same applications, but with a completely different set of code. And it has a completely diverse community of different types of people and its own funding sources. So it's not relying on the same things as different Linux distros. So if there's a problem with the vendor, whether it's just your relationship with the vendor or the vendor's financial health or whatever it happens to be, looking at FreeBSD, it's completely isolated from that and not going to be disturbed by it. It also has a different license, which may or may not come into play, but its liberal copy-free 2-clause license reduces your compliance risks, or just the amount you'd have to consider of a second license that you're going to have to get authorized to use, and so on. And you can do very much the same things Alex was talking about with having an immutable operating system and running containers on top of that, and using the tools that FreeBSD provides, in this case, Poudre, to build both customized versions of the host operating system image that are, everything you need baked in, made once, and then splattered out many times. But you can also use it to build the container images and have those container images, again, include certain packages that you want and layered just with, I want, just this base with these components removed and these components added, and get exactly the system you're looking for, and being able to have an alternative that can run the same software. And we'll talk more about how, you can mix and match these different components in a future slide. So looking more at selection criteria, when you're trying to pick which component to use for each of these things, whether it's the operating system or the web server or the name resolution library or the TLS library or whatever, there's a couple of basic things you want to look at. First, is the component well suited to the use case I have for it? Lots of applications and components and libraries can also do X, but if it's not something that a lot of other people are using it for that as well, then maybe it's not as good of a choice, because you want to kind of stay on the well-worn paths when you can, because there's more support there. Then you have to consider application support. Like we talked about, if you're going to run a third of your infrastructure using a different TLS library, do the applications you need to use for your business actually support that TLS library? And if not, how can we get to the point where they do, so that we can actually have this diversity? Or, is there a different alternative we can select that does actually support those applications? And then we have the same thing with the diversity of dependencies. Like we said, programs like curl and a lot of other open source applications do have support for multiple different dependencies. It can use any of these libraries for DNS resolution and any of these libraries for TLS and so on. And so if you are building packages to use in your container, sometimes it's just a matter of one set of those uses this set of dependencies and the other uses this other one, so that if there's a vulnerability in one of those DNS resolution libraries, we know it's not impacting every single instance in production. And we can tell our load balancers, prefer the machines that are running the version that's not a problem. And we can quickly redeploy the other machines temporarily onto, all of them running the version that's not impacted by the vulnerability. And it allows us to stay up.
We saw just this week with Docker's announcement around Docker Hub, how vulnerable we can be if some of our dependencies go away. Because most Docker images start with a line that says from, and then the name of the image next to it. So from Ubuntu or from Alpine or whatever it might be. Mm-hmm. And if Docker Hub went away, yes, you can clone the Git repo that the application you want is, the code. But if that upstream from image isn't there, you're not going to be able to recreate it completely from source. And so this idea of having diverse dependencies expands just, exponentially beyond the operating system as well into, things like your container hosts and the images they're running too.
Exactly. And like you're saying, we want to make sure that at every level we have at least 2 different components that we're using, and then we can use some for each, so that as soon as there's a problem with any one of those components, we still have some fraction of our infrastructure that can remain up and usable, and we can quickly redeploy the parts that are using something that's vulnerable to at least be using the alternative in the meantime, but allowing us to get both the immediately we are already covered because a third of our servers are running something different, and we can get back to 100% of our capacity very quickly with just a redeployment.
Remind me why centralizing everything on Cloudflare is a bad idea again?
Yeah, exactly. And so the last thing, especially with open source, is considering the health of the ecosystem. Is this component open source? How healthy is the community? How frequently are they doing releases? Is there active development? Is the sponsorship of that project in a good state? And if you do have a problem and need to report a bug, how responsive are they to that? Or if people are reporting vulnerabilities in it, how responsive are they to that, and how quickly do fixes get out? Because you don't want to be stuck on a component that nobody's maintaining anymore, and it's going to be up to you when that vulnerability is announced and you have nowhere to go. And so now we want to talk about actually implementing this diversity and eliminating those single points of failure. So, a common analogy we use when looking at the fact that the strength of a whole is really just the strength of the weakest component of that whole. So we think of a chain where each link is connected together, but if one link breaks, the chain's not a chain anymore, it's broken. But a chain is only as strong as its weakest link. But if every link in the chain were paired, if doubled, then the failure of any one link wouldn't break the chain because there'd still be that second link at each spot. And if we think about that as our, support chain for our infrastructure, if we have 2 options at every link, then we know that even if one of them goes away or breaks or is vulnerable or whatever, we're still able to continue to operate and have a complete chain. And so our infrastructure is the same. We want to avoid any single point of failure where everything relies on a single link in the chain, and that will build more resilient infrastructure. So actually implementing that is, like we say, we don't want all exactly the same hardware. So whether that's just 2 different vendors or 2 different generations, but also nowadays it means maybe actually looking at 2 different CPU architectures. Having some AMD and some Intel maybe works, but also now's time to start looking at, should some fraction of our infrastructure be running, ARM v8? And actually mean that if there is another Spectre meltdown type of thing, maybe we have a CPU now that's not actually impacted by that. And then the main focus we've been talking about today is using multiple operating systems. By implementing multiple operating systems in your infrastructure, you provide that extra layer of protection against any potential vulnerability or the likelihood of a class break or anything that might go wrong and would take out all the machines using that component. And if it's the operating system, that could be all of your machines. So if you're using 2 different operating systems and say 2 different web servers and 2 different TLS libraries, so in our example here, if we had half of our infrastructure running FreeBSD and half running Linux, and then of each of those, half running Nginx and half running Caddy, then we know if there was a vulnerability in Caddy, now we have, a quarter of our machines are Linux and Nginx, and a quarter are FreeBSD and Nginx. So we still have half of our capacity, and we're still diverse at the operating system level. And we can quickly redeploy those containers that we're running Caddy to be running Nginx until there's a fix for Caddy, and we go back to having diversity all the way up and down the stack.
Would you promote putting 50% of each of those, so 25% of Nginx and 25% of Caddy on the FreeBSD side, and then the same on the Linux side? So you're kind of splitting,
Exactly.
your web servers across.
Yeah, so that if if the problem is at the operating system level, you still have half your capacity. And if the problem is at the web server level, you still have half your capacity, and you still have the diversity of operating systems in the meantime. And if you can think it's the same thing, and then when you're compiling your Nginx, if you can compile some of it to use OpenSSL and some of it to use an alternative, or again, like we're talking about dependencies all the way up and down that we could do, then we have that much more richness. And again, any one link in the chain goes away, we still have the backup link at each of those stages, and we don't end up with a broken chain.
So next, we're going to look at diversity objectives. And the idea here is to look at some of the key points around how we can make our infrastructure more diverse. And the first one I want to touch on is avoiding vendor lock-in. This should be a fairly obvious one. But if we look across multiple industries, we can see vendors love to lock people in. It's part of their business model in a lot of cases. If you can, look at, say, a housing contractor who's remodeling homes, they will go to a specific flooring company and say, what systems have you got that will save me time and money? And the flooring system company will happily say, sure, here's my system. I will train your team on it, and we'll sell you a toolbox full of tools that are specific to our system. And along the way, everybody makes a bit of money and can, mark things up a little bit, but you're locked into that specific flooring manufacturer's system because you need to use their particular widgets to install their particular thing. Linux, FreeBSD, software vendors in general, all are locked. You're locked in at some point, no matter what you do anyway. And there's lots of reasons for that. Some are insidious and some are just the realities of the situation. We'll touch on more on some of the points with regards to the specifics between different operating systems later on, but it can be as basic as, just file paths are different, right? In your infrastructure as code, you will find that you'll need to account for the fact that you could be running Fedora in one place and FreeBSD in another. And your code needs to account for the fact that the packages will be named slightly differently on those two targets. That's a form of lock-in. It's a very minor form. A worst case would be holding data hostage in a particular style of database, for example.
Yeah, and we can see the same thing even just with, all of our staff are trained on Red Hat or Ubuntu, and it's not really locking us in. It's not insidious, but it just means that we have better velocity there. And until we've cross-trained, we're kind of have this penchant to always go with what we know. And thinking as in diversity is that we want to make sure that we're always using two disparate things at every step so that we don't get locked in. And if something does change and suddenly the thing we were using everywhere is not an option, we have the agility and the ability to switch to something without having to incur all of the retraining and all the problems and making it a long, desperate transition.
We see this so much in the home automation space as well. It's one of the reasons I think why Home Assistant has been so popular over the last few years, is it kind of translates those individual vendor lock-in languages, if you like, that each light bulb speaks to a specific vendor's app, or, speaks a specific, Zigbee or a Z-Wave or whatever protocol. Home Assistant sits in the middle and acts as like a translation layer between all of those different things. And that's what we're trying to have here is, to avoid being locked into a specific vendor, you can run a different OS that will let you avoid being locked into a specific way of working, a specific way of thinking and doing things. And in the long run, that means you're going to have a lot more resilience from vulnerabilities as well, which is always a nice thing. This is another point we have on our slide here. And so by, not using the same kernel across multiple different systems, you could argue that you could run two versions of Linux on different kernels, or two versions of BSD on different kernels, and get much the same benefit, assuming that that vulnerability doesn't backtrace all the way through several years worth of kernel patches. Yeah. And so the idea here is to run two completely different sets of a kernel, a Linux kernel and a FreeBSD kernel, and hope And you know, some of this is based on hope, but you got to hope that the vulnerability that you have in one isn't present in the other, or if it is, it gets patched before the other one. And you know, you can pick the one that suits your situation the best.
Yeah, and the same thing applies to performance. That if you're using completely different kernels, if one has a crippling performance problem, it's not likely to affect the other as well. And if it does, it's probably something more at the hardware level. And again, if you have disparate hardware, right, like you were saying, if half of our NVMEs are using different NAND with a different controller, then it's not likely to be able to affect everything at once. But part of that is, you know, some of that won't exist today, and we need to build the feature parity so that there is, you know, another TLS library that can actually compete with OpenSSL, or, you know, make sure that we don't end up with there's only one web server that works with all of these applications, or whatever it happens to be. And the other part is, you know, the ecosystem can only remain strong if everyone contributes and we avoid concentrating all the power in a single entity. So, you know, if everything lives under the Linux Foundation, then we don't actually have disparate communities. We have one big one that's all dependent on that one funding source.
Yeah, couldn't agree more.
Yep. So another core thing to doing this is avoiding duplicate work, right? If we have two of everything, we don't want to have to do every task twice, because it will just double the amount of admin work that we have. And that's where, you know, we can look at ways to make things not have to be as disparate. One of those is just automation can make the big difference, right? If we're using something like Puppet or Salt that already understands some of those differences between the different operating systems, and we can make one rule that says, you know, configure this in this way, and it will automatically apply to all of the different disparate OSs or packages or whatever we happen to have. And then we can also there consider the push versus pull mechanism for config management, and that. But another thing, you know, if we're not doing the, you know, complete container thing and are using packages, then we can look at using the same package manager on both operating systems. And that works both ways here. You know, Red Hat RPMs, all the tools for that run on FreeBSD, and you can build RPMs containing FreeBSD binaries. And that way you have, you know, RPM repos that have, you know, support FreeBSD and Linux. And this way you don't have to deal with two different package managers, right? When you're teaching Puppet, and you can make sure your packages are named the same and everything, so everything will work the same. And you can also do the inverse. FreeBSD's package manager also runs on Linux. Or you can look at an alternative like Package Source from NetBSD, which runs on something like 27 different operating systems and also a lot more odd hardware than you would find with most package managers. And again, that gives you one source for all of this stuff that you can use across multiple operating systems so that the interface you get to it is the same. But the binaries are still going to be specific to the operating systems. And so they'll be disparate, and you can configure different options and like we talked about, the diversity of dependencies. But it means the interface you're getting to it is common, so that it's taking away some of those differences between the operating systems or components, so that you don't have to do all the work twice for two different package managers. And we can look at the same thing with containerization and common runtimes. You know, we've seen with things like Docker and Kubernetes that we now have common runtimes where you can run the same container, but using different infrastructure, so that you can not have to depend on just one component there. And that as we get more and more of these things having a spec, that means that somebody can write an alternative to it and be able to run those same images, means that we can have the diversity even at the container level.
A couple of things to watch out for. We touched on this briefly already, but between Linux and FreeBSD, which are the primary targets of this webinar, at least, there's a lot of similarities. But if you boot up a FreeBSD system and you're a Linux guy, that's my role in this conversation, you'll go and run some commands and you'll be like, these things aren't quite where I expect them. So there's a few things you've got to be aware of, just some pathing differences. Largely speaking, the philosophies of the operating systems are broadly similar. I know there's some, larger picture licensing differences and what have you, but It's still, everything is a file pretty much in BSD, same as in Linux. Those concepts still translate, POSIX still translates, all that stuff. Just things are in different places, different directories. And the same is true of packages as well, and this is true not only across FreeBSD and Linux, but it's also true between different Linux distributions. You got to be careful, that your infrastructure as code. I've got to find a better way of saying that. But you got to be careful that code has the logic in it to deal with the different operating systems and the different names that these packages have. On top of that, you got to be careful that different systems release at different rates. We already touched on the fact that Arch runs at a different pace to RHEL, for example. But some operating systems target stability and some target breaking things and fixing them fast. And you've got to pick the right one for your needs. The last thing that I want to touch on this slide is that not all applications are built for all environments. So you might find that an application is Linux only or BSD only. And those binaries will require potentially you to get your hands dirty and compile them for the operating system that you're running, or reach out, perhaps if it's an open source project, to the project and see if they could start packaging it for your needs and your requirements. The other thing to consider is that certain applications might rely on kernel level features. And a great example of this is WireGuard, for example. I think it's been merged into BSD late last year. Yep, it's now in the kernel. But prior to that, that was a good example of an application that was running in the Linux kernel, but was running in user space in BSD, for example. And those things have performance implications. And so if your application is taking advantage of something that's in a kernel, you got to make sure it's in both.
Yeah, and FreeBSD has a lot of advantages on the in-kernel TLS and being able to push a lot of traffic out of a web server or anything like that with all the TLS encryption handled. But again, that's all depending on that specific kernel or even sometimes hardware offload. So you need certain NICs that have support for the processor on the NIC doing the TLS for you rather than your, general purpose CPU.
Speaking to you right now through an OpenSense firewall, so it's doing a good job.
So yeah, if you're interested in this kind of thing, you should definitely get in touch with Clara. Clara is a leader in open source package management solutions, providing expert support and advice to customers and partners worldwide for building custom packages for both the whole operating system image or just packages, and also being able to package up containers and just deal with some of the complexity of trying to implement this diversity and build packages that will run on multiple operating systems. Our team of experts can help implement your OS diversity plan and help you manage that IT infrastructure efficiently and make sure that you're able to keep it up and adapt when something does go wrong. So if you're interested in that, check out our package building and deployment package solution or our FreeBSD infrastructure audit solution, and we can help you look at your infrastructure and decide where the most value might come from implementing more diversity. So we have some time for questions. Does anybody have any questions? Here's a great one. Anonymous asks, can you share your thoughts on how legal and regulatory requirements can force companies to use closed source technologies? Are you aware of any success stories in which companies overcame inertia to replace closed source technologies in a compliance-heavy environment? I worry that the requirement to install closed source widgets that only support Windows and Linux will stifle diversity of OSs in the corporate world.
I have several in mind, but I don't know if I can share them because, in my day job, I work with several companies where I think this question could apply to, and have worked with several in previous jobs again where it could apply to. And a great example of this is stuff like an Oracle database, for example. It's not an open source technology, but you could argue that actually for certain situations, that closed source technology is the right fit. I'm talking about banking here, for example. Just the sheer volume that they're dealing with and some of the support mechanisms that those big companies can offer is a good thing in certain situations. However, I've built my life and my career around open source. So my argument here is heavily biased towards that as an answer. And I think where possible, we've seen over the last decade plus that open source innovation and having lots of eyeballs argument on the code provides a superior experience in the long run. Now, as for how you convince your CIO that that's the case, CFO that that's the case, sorry, well, that's probably up to you to put that business case together. But I don't
I
think
think the other part is our industry needs to do a better job of explaining this to regulators. We've seen some improvements, especially in the EU, of making sure that regulations don't specify specific technologies or a requirement to use a certain closed source technology. And I think, being able to educate legislators on these types of issues and making sure that the regulations don't end up heavy-handedly, dictating that you have to use Windows for this. There's some great writing from a Canadian scholar,
would be Canadian.
Michael Geist on how easy it turns out to be to convince a lot of regulators of these things if somebody would just come and explain it to them. So I think part of that is we need to educate the regulators to do a better job of writing the regulations so that it leaves the opportunity for open source, or even going further and getting to the point where we regulate that, if we regulate that you use this thing, it has to be open source so that, it can be modified and repaired by someone other than just a vendor.
Absolutely.
Next, another one asks, how do you justify the expense and complexity of this diversity deployment in an already monocultured enterprise? Are there any documented approaches to help enterprises find the optimal point between being diverse enough for resiliency while being affordable and manageable?
I think this is a system architecture question, really, and it touches on all of the points that we've been making for the last 45 minutes or so. The answer to the question is, how do you justify the expense? Is how do you justify the expense of downtime from not doing this? Can you afford the downtime from an OpenSSL vulnerability, for example, or having a Spectre or a Meltdown, style performance hit on your CPUs, or relying only on AWS, for example, or there's lots of other options. There's lots of other examples.
Yeah, exactly. It's like, would you have your data center only have one power feed? Would you, deploy to the cloud using only one availability zone? And it's basically just another one of those. And the other thing is, if you're applying this properly and avoiding some of the pitfalls we talked about, the expense shouldn't be that high to just use a second operating system. A lot of it's one-time cost of just dealing with those slightly different paths, and a lot of tools have already dealt with this for you and have abstracted that away. And so if you're using something like Puppet, it already knows that, to install a package on FreeBSD, I do this, and on Red Hat, I do this, and on Ubuntu, I do that. And so the expense shouldn't actually be that high. It's just a matter of architecting and picking those components. And, that is a process, but it doesn't have to be that heavyweight.
I have a question for you, Alan, from anonymous attendee. Are there any things to watch out for when sharing ZFS pools between multiple operating systems, perhaps in a high availability cluster that performs an export-import on failover?
That's a great question. The main one to watch out for is if you're having ZFS control NFS shares, the configuration will be different between Linux and FreeBSD, for example, and the config won't work in the other operating system. That's something that's currently being discussed upstream in OpenZFS about maybe kind of in the background having that property be share nfs.linux and share nfs.freebsd or something, so that you could have the correct settings for both live in the pool at the same time to avoid that. Outside of that, they're very compatible. The biggest challenge there would just be making sure whatever operating systems you're using on both sides have at least approximately the same version of ZFS. Or just making sure that when you create the pool, you do it with the lowest common denominator of features. Because using newer ZFS is fine. You just can't start using the new on-disk format features. Otherwise, you'll have the other machine not be able to import once you've written data.
I saw a message just this week on my ZFS pool saying, do you want to enable all these new features that have been added? Do a Z-pool upgrade. But once you do this, you can't go back to an older version. So it's important, like Alan says, to make sure it matches on both sides.
And starting in, I think, 2.1, ZFS actually has a feature for this. When you create the pool, you can say -o compatibility equals, and then some baseline, like a specific version of ZFS or even a version of Ubuntu or FreeBSD or whatever. And it makes sure that it will create a pool that is compatible across those. Some future work that needs to be done there is not nagging you about upgrading if you specifically said, I want this baseline and I don't want to upgrade right now. Because yes, that little message there is just so tempting for people. And if somebody pulls the trigger on that, that's not going to.
I can't avoid updates, especially if it nags me. Oh, I'll just do it.
Yeah. Someone else also asked, said they got the time zone wrong and they were late for the talk. Will this be available later? Yes, the complete recording will go up on YouTube in a couple of days. And one last question. Do you see greater success or adoption when the underlying OS is abstracted from the customer, for example, as a service? Yes. Some of the places I've seen this concept applied most successfully is things like TLD operators. So the people that run like whole country code top level domains and so on will use diverse operating systems and diverse DNS servers and this across a bunch of machines to make sure that if there's a problem with a certain OS or a certain name server or any other component along the chain, that they're able to keep serving everything without having to swap out parts of their infrastructure. Okay, I think we're out of time for today, but thank you all for joining us, and we'll hope to see you next time.
Thank you.
And again, if you would like to get in touch with us, please do that. And as I said, there's services on our website if you would like help actually implementing this diversity at your organization. Thank you, everyone.